When using a random sample and studying population of interest, we deal with sampling errors. So what is a sampling error? We define the sampling error simply as the difference between a sample statistic and its corresponding population parameter. Examples include, on the top row is the sampling error of the mean, where we take the difference between a sample mean and the population mean, right here. On the second row, the sampling error of a standard deviation, right here. The third row is a sampling error of the variance, here. And finally, the fourth row shows the sampling error of the population, right here. The study of inferential statistics and of hypothesis testing in particular, as we will see in the next few chapters, focuses on determining whether the sampling error we observe is due to random chance or not. The sampling distribution of the sample mean is a probability distribution consisting of all possible sample means of a given sample size selected from a population. This concept is the basis for the central limit theorem, which is introduced in a later slide of this chapter. In this example, we develop a sampling distribution for a small population with 7 observations, where we take a sample consisting of 2 observations each time. Because the population is small enough, we could list completely all the possible combinations of sample size 2 taken from a population of 7. We answer the following questions. 1, what's the population mean? 2, what's the sampling distribution of the sample mean for samples of size 2? 3, what is the mean of the sampling distribution? And 4, what observations can be made about the population and the sampling distribution? What does the population mean? Using what we learned in Chapter 4, we compute the population mean by adding all the 7 observations and then dividing the sum by 7. The population mean is $7.71. Next, we develop the sampling distribution of the sample mean. But before we can do that, we need to list all possible samples of 2 without replacement from the population of 7, and then compute the mean of each sample. Using the combination formula we learned in Chapter 5, we determined the total number of possible samples of size 2 that can be taken from a population of 7 as 21. An exhaustive listing of earnings of 2 employees or sample size 2 taken from a population of 7 is shown on the table in this slide. The mean of each of these samples is also computed. On the next slide, we summarize these 21 sample means by way of a frequency distribution table. From an exhaustive listing of the 21 sample means in the previous slide, a frequency distribution table is developed wherein the number of times each of the 4 unique sample means, as observed from the previous slide, has occurred is counted. For instance, the sample average of $7 was observed 3 times in the list. The sample average that occurs most often is $7.50. The frequencies are then converted into relative frequencies as shown on the right column of the table. So for the sample mean of $7, it occurred 14.29% of the time. We show these relative frequencies in graphical form in the next slide. In a previous slide, we computed the average of all 7 observations which represented the population. The average was $7.71. On the top portion of the slide, we compute the average of the 21 sample means we listed earlier. The average of the sample averages is exactly equal to the average of the population. Okay, this will always be the case. That is, the mean of the sample means, denoted as mu sub x bar for a given sample size, will always be equal to the mean of the population mu. Of note on this slide is the comparison of the distribution of the 7 individual observations of the population, which is illustrated on the left graph, and the distribution of the sample means, which is depicted by the graph on the right, observe that the distribution of the sample means approximate the shape of the normal distribution. We make the following observations of what we have observed in the example. Number 1, the mean of the distribution of the sample mean, $7.71, is equal to the mean of the population. Number 2, the spread in the distribution of the sample mean is less than the spread in the population values. As the size of the sample is increased, the spread of the distribution of the sample mean becomes smaller. Number 3, the shape of the sampling distribution of the sample mean and the shape of the frequency distribution of the population values are different. The distribution of the sample mean tends to be more bell-shaped and to approximate the normal probability distribution.